is Mr. Gillum, and today we're going to be dividing decimals again, and this is on page 96 of your instruction book. So the average walking speed is 3 4/10 miles per hour. How many hours would it take to walk from Boston to Seattle, a distance of 3,020 and 22 hundredths miles? So I guess what we could do is we could start by estimating. And when you estimate for something like this, just get a ballpark figure. You really want to kind of estimate to numbers that are close, that are easily calculable. So like in this case, 3,020 and 22 hundredths would be like 3,000. And 3 4/10 would be like 3. And I know that I need to know how long it takes for him to go 3,000 miles if he goes 3 miles every hour. So do you know how many 3's go into 3,000? So about 1,000 is what I'm thinking for this solution. So when I'd actually find the exact answer, it should be somewhere near 1,000 is what I'm thinking. When I model this with the long division algorithm, what I like to do, what I prefer to do, is I like to move the decimal out of the conversation altogether by using a different equivalent problem. So in this case, it looks like they're going to take a little different approach. We learned yesterday that we could do this. We could say, if I want to think about 3,020 and 22 hundredths divided by 3 4/10, I could think of it like a fraction. And I know that that fraction would be equivalent to a lot of other fractions. Multiply it by 2 on the top and bottom, 3 by the top and bottom, 5. But there's a strategy where if I want to get rid of the decimals altogether, I can multiply it by 10, 100, 1,000, 10,000, something like that. One of those numbers that I know just moves the decimal. Now, in order for me to not have a decimal in either the numerator or the denominator, I will need to move it 2 spots minimum. Even though that's a little too far on the bottom, it will make sure that my top number and my bottom number no longer have decimals. So if I multiply the top and the bottom by 100, I will accomplish that. And that's the strategy that I'm taking so that I have a fraction with no decimals in it anymore. It has to do with equivalent fractions. If I keep it the same, you can see that this decimal will be way over here. I do need to keep that 0 because that's in front of the decimal. Okay, and so now I have a problem where I could try to figure out what 302,022 divided by 340 is. Now, this strategy is not going to be a perfect strategy because I can see that 340 is a huge number. It's bigger than what we've ever done. There's 3 digits on the outside. And so if there's another way that we could approach this problem, it might be more beneficial. And I think that's how they're modeling this problem in this case. Instead of considering about the equivalent fractions and removing the decimal place, it's not going to be a great strategy this time because this number is so large and this number is so large as well. And so in this case, what I prefer you to do is I'd like you to think of it as I would do it this way. I would say 3,020 and 22 hundredths divided by 3 4/10. I would just move the decimal, the necessary number, to get the divisor without a decimal anymore. So I'm just going to move it one place. I'm going to move it one place here as well. Really what I'm doing is I'm multiplying by 10 when I'm doing that. Okay, and just that one spot. Now I only have to mess with 34. I just need to make sure that I align my numbers in the correct spots, and my decimal now goes there instead of where it used to be right there. So you can see they kind of take the same approach here. Really, the number outside the division is the number that we need to prevent from being a decimal. Okay, that's the most important number. So we're going to actually work through that here in just a second. Let's take a look here. It says that if we look at the estimated, about how many hours would it take to walk from Boston to Seattle? Well, it would take about 3,000. About 1,000. I know that it would take about 1,000 because 3,000 is close to 3020, and 3.4 is close to 3, and yes, I could have rounded 3.5, or I could have rounded a little differently, but I want an easy calculation that's going to just be a ballpark figure, and I want the numbers to be like easily calculable. So I chose 3003, and that's about 1,000 hours. So our answer should be somewhere around 1,000. When we look at the fractions, why do we multiply the numerator and denominator by 10? Well, I'll show you here. When we look at this, only by 10 because really it's the divisor that we want to be no decimals in. That's the most important one, okay? Denominator, known as the divisor. Decimals, no decimals in it, okay? So that's why we're doing that. We don't want any decimals in our divisor. The decimal in the divisor is tenths. To get a whole number, we need to multiply by 10. Then you have to multiply the numerator by the same number, of course, to keep them equivalent, to keep the fractions equivalent. So explain how moving the decimal point one place to the right is the same as multiplying the numerator and the denominator of the fraction. Well, we keep the fraction equivalent because we multiply the top and bottom number by the same number. When we multiply something by 10, we move the decimal place 1 to the right. We just need to make sure it's equivalent, so we keep it the same on both the top and the bottom. If you think about it, when we have any fraction multiplied by 10 over 10 or by 100 over 100, I know 10 over 10 is really 1, and that's why it's equivalent. I'm just really multiplying by a form of 1, so it's not really changing the value. It says, how many hours would it take to walk from Boston to Seattle, and how can you estimate to help decide where to place the decimal? So basically it's saying you need to do this long division, and if you're not sure where to put the decimal, you need to put it as close in between the two numbers that makes it closest to 1,000. So let's go ahead and do that long division, and we're going to try to do it over here on the side here. The two numbers were 30, 20, 22. Divided by 3 4/10. Okay. So again, I want this divisor to be just, I just want it to be a whole number. So I'm just going to move that decimal once, but really what I'm doing is I'm multiplying by 10. Do the same thing here. I'm just multiplying it by 10, and that's keeping my fraction equivalent. I'm keeping the same. I'm going to have the same quotient. I just need to make sure I put my decimal in the correct place. So now I have my decimal there in between the 2 and the 2, not in between the 0 and the 2. So now when I continue on, I'm going to solve this the same exact way. I see that 34 doesn't go into 30, so 34 must go into 302 a certain number of times. Again, I go back to always multiplying by 10. I know 34 times 10 is 340. 1 less than that would be 306, so 2 less than that would be 8. I think that 34 times 8, whatever that is going to be as close to 302 that I can get. So let's figure out what 34 times 8 is. It's like about 272. So take away 272, 0, borrow 30. I bring the next number down. And so basically I just had the same exact same 300, 302, same thing. I think it's going to go in 8 times. It's going to be as close as I can get. I'm going to subtract again 272. I already made that calculation. And I'm going to borrow. Looks like we have 28 this time. Now bring my 2 down, and now I have 282. So again, really close to 272. So I'm going to have that 8 up there, and I'm going to subtract 272. That leaves me with 10. The final number that I need to bring down is the 2. And I just so happen to know that 34 times 3 equals 102. So it looks to me like I have no remainder. And so I know that the number of hours that it takes will be 888 hours and 3/10 of another hour. And so if I wasn't sure where my decimal point went, I would not put it, if I had to guess where it went, I wouldn't put it here because That would be 8 hours, and I know it's supposed to be closer to 1,000. That'd be 88. That'd be 888. That would be a great place to stop because 8,883 would be way too far. So if I was just guessing and I didn't understand where the decimal was supposed to be, according to how I moved it in the beginning, I would be able to, at least because of my estimate, know where it should go in between the 8 and the 3. So that's the closest one that's to 1,000, so that would be the appropriate place to put it. So when we divide by decimals, we want to make sure that the divisor has no decimals in it. And so we multiply by what is called a power of 10, meaning 10, 100, 1,000, whatever is necessary to get the divisor, the number outside the division out here, into a whole number. Whatever I multiply that by, I also need to multiply the dividend by to keep the quotient equivalent. And then we divide the same way as we do with whole numbers. So it says that Annette had a 24-karat gold necklace with a mass of 2 3/10 grams. She sold it for $123.51. What was the price per gram of her necklace? So when I see per gram, I think of per 1 gram, and that's a unit rate. And so I want to know per gram. I want to know what how much per gram. That indicates to me that if she made $123.51, I need to know how much each gram was. I need to divide 123.51 divided by 2 3/10. So let's set it up like we did today, not like yesterday. And we're going to go ahead and draw our long division bar and everything, and divide. Now before we get started dividing, because there's decimals involved, before there are decimals involved, we're going to go ahead and multiply this by 10. As well as multiply this by 10. That's what I'm doing. And now I know the decimal place is going to go right between the 5 and the 1. I need to make sure I write my numbers down vertically. Now I can calculate just like a whole number. I can just treat this as a 23 and treat this as 1,235.1 or 1 and 1/10. I know 23 will go into 123 5 times. 23 times 5 is 115. Bring my next number down. 23 will go into 85 3 times. 23 times 3 is 69. Now I knew 3 times because I knew 3 3/4 would be 75, and that's a little less than a quarter. So I didn't think it would go in any more than that. So I need to choose 3. And that'll bring me on my final number. That's 1. So I know 23 times 10 is 230, so 23 times 5 would be half of that, which would be 115. So it's going to be, I'm going to guess, let's just guess and check, 6. Let's see where 6 gets us. The reason I think 6 is a bad guess is because I know 6 times 3 is 18, and this doesn't end in 8. So I think a better guess would be 23 times 7, because I know 7 times 3 is 21, and that ends in a 1. So I think 23 times 7 is going to be a better guess, actually. 161. Yes, we were correct in that guess. And when we subtract 161, we get no remainder. So I think that each gram was worth $53.70. We did not write a 0 here, but when we talk about currency, we talk about with the 0 usually. So $53.70 per gram. At maturity, a stalk of corn is 76 56/100 inches tall. It took 2,392 5/10 hours to reach that height. How much did it grow per hour? So again, when I talk about per hour, this is a unit rate from what we learned about ratios and proportions. I want to know per hour, and I have how many inches tall it is. So I really need to figure out what is 76 divided by 2,392 5/10. It would be very tempting to put the big number first, but that's not really how this all works, okay? Always go in the correct order. So in this case, even though that's a smaller number, 76 56/100 is going to go on the inside, and 2,392 5/10 is going to go on the outside. We want to make sure that our divisor only has one decimal place, or has no decimal place, so we're going to multiply by 10 on both. Okay, Now we just have this beast of a problem that we got to figure out. We may need to add a 0 on the end in order to fit this large number into this one here. Let's go ahead and divide this in class tomorrow.